Right, so what we're going to do is kind of vary this attraction weight outside of the solver before we come into the simulation, right? So if we come outside and then drop a VOP network, or not a VOP network, sorry, attribute VOP. Okay, so we're going to run over the points here. Okay, and then dive inside here. And what I'm going to do is we're going to use a couple of noises. We'll use, oops, if I type AA, we should get anti-aliased noise. Okay, plug the position into the position, and then the noise we'll just do straight into color for now, and then we can see that straight away. We're getting values there. And if we check the geometry spreadsheets, we can see what values we're getting. So we're going from minus 0.43 to 0.36. So this is generating a noise between, I think if we check the information, not there, it will be between minus 5 and 5. I don't know if it says here somewhere. Either way, we can pretty much see it from the results there. Okay, so we just need to keep that in mind. So I'm going to push up the frequency here. Let's do this one to 10. Okay, and push up the amplitude. So we'll change the values that we've got here. So now it's from minus 0.8 to 0.03. Okay, and let's see. What we're going to do is write this out to, if I drop a bind X, I'm sorry, not this one. We need to bind export to get the attribute out of this context, okay, to put it onto my actual geometry, because we got outputs here for these attributes, but we don't have one for the attraction weights. Okay, so we're going to be making it and exporting it here. So it is a float, so that's fine. We just need to give it the correct name, the same as what's in the solver. Okay, we can't make it any different or it won't work. So attraction weight, like that. Okay, so this is the same as if I go, you can see there it's already having an effect. Right, if I turn that off, turn it on, you can see the effect. So if we come here, hover over, you can see the name of the attribute there, the parameter attraction weight. Okay, so yeah, we don't want these values though. Okay, well, you can see from that they're too high. So what I'm going to do is drop a excuse me, a fit range, and then we can use that to redistribute those values. Before I do that, I'm going to make another one of these. Okay, to give us something a bit more interesting. Bring that down to 2. I'm just plugging into the color here just so we can see, by the way. It doesn't matter. It's not going to affect our sim. So there's we get bigger shapes, and here we've got smaller shapes, and what I'll do is just add them together to get a mix of the two. Plug that into the color. Now we get something a bit more interesting. Okay, and then I'm going to, maybe in this one actually, I'll bring down the amplitude as well to 1 there. Okay, and yeah, what I'm going to do is plug this into our fit. Okay, and then if we take a look at our geometry spreadsheet now without the fit, we could, if we find the attraction weights, you can see the values. So they're going from 2 to minus 2, minus 2.2. Okay, so I'm going to do this. So what we could do is take those values from that I just read to you, that we just found. So from minus 2.2 to 2, so minus 2 to 2, and then they will be redistributed to values between 0 and 1. So there we go, values between 0 and 1. But I want to kind of crush them down a bit, so I'm going to do minus 0.5 to 2, and then the outputting values would be between 0.5 and 1. So going into my solver, I've got a range of attraction weights between 0.5 and 1. Okay, and we can see that when I plug in the color, it'll be a lot more. It's hard to see here because the difference in value is quite subtle, but it will have an effect on our the simulation in here. Okay, well, and we will have to push up the substeps and the push down the grain size quite a bit to get the results that we want.